Today we're going to start our unit on radicals, and our first lesson we're going to look at square roots and cubed roots. So our first question that we have to ask ourselves is, what is a square root? So if I write something like this, alright, when there is no little number here, then we assume it's a square root. Okay, we don't have to write the 2 there, we just assume it's a square root. And basically what it's saying is, what number multiplied by itself twice equals n. So a nice example is the square root of 4. So what number multiplied by itself twice equals 4? 2. Square root of 9. What number multiplied by itself twice equals 9? 3. What about a cubed root? So a cubed root is going to look like this. There's a little number here, and this is noting that it's a cubed root. So what this is saying is, what number multiplied by itself 3 times, maybe I'll just write 3, equals n. So a nice example is the cubed root of 8. So what number multiplied by itself 3 times equals 8? 2. Cubed root of 27. What number multiplied by itself 3 times equals 27? 3. And if you're ever not sure, we're going to use factor trees. So remember prime factorization from last year, we're going to use that same method. So some terminology that we have to be aware of. So this little script here is called our index. Okay? Our x is called our radicand. And the entire thing is called a radical. So far, I think everything's easy enough. Alright, so we have a few examples. So our first one is the square root of 64. Okay, well, the square root of 64, what number multiplied by itself twice equals 64? I hope you're all saying 8. The second example is the square root of negative 16. What number multiplied by itself twice equals negative 16? In fact, we call these non-real or imaginary. And that's because, can you ever multiply a number by itself twice to equal a negative? And the answer is no. So, for example, some of you might have said, well, negative 4. But remember, it's negative 4 multiplied by negative 4. A negative multiplied by a negative is a positive 16. Some of you might have said 4. Well, positive 4 multiplied by positive 4, again, is going to be positive 16. The square root is a number multiplied by itself, that exact self, and therefore the sign has to go with it. So our answer would just be non-real or imaginary. Example number 3, we actually did this above, the cubed root of 27. So what number multiplied by itself 3 times equals 27? And we said that was 3. What about the cubed root of negative 27? Okay, so now we have a number multiplied by itself 3 times to equal a negative number. Think about negative 3 multiplied by negative 3 multiplied by negative 3. Well, negative 3 multiplied by negative 3 is a positive 9. Positive 9 multiplied by negative 3 is negative 27. So we can take a cubed root of a negative number, because a number multiplied by itself 3 times, a negative multiplied by itself an odd number of times, will still be negative. So in fact, the answer to this one is negative 3. So as a general rule, okay, you can take an odd root, so the cubed root, a fifth root, a seventh root, etc., of a negative number. You cannot do this for an even root. So we cannot take the cubed root, or sorry, let's go square root of -4. I cannot take the fourth root of -32. I cannot take an even root of a negative number because a negative multiplied by itself an even number of times would always be positive. Okay, so converting between entire and mixed radicals. Okay, so what I want you guys to understand is that I can actually write a root as, in exponential form. Okay, so I can actually write x, and the root we say 1/2. This number in the denominator is telling us what kind of root it is. So for example, if I was taking the cubed root of x, this would be x to the 1/3. If I was taking the fourth root of x, then I would have x to the 1/4. Okay, so the nice thing about being able to write this with exponents is that we can use our exponent laws from our second unit that we did this year. So I can write this as, so it's the square root, so this is x multiplied by y, and if I write it in exponential form, it would be 1/2. Now, what's nice about this is we can use the power of power rules. So this half is multiplying everything inside of here, and we can use this rule because it is a monomial. So we get x to the 1/2 multiplied by y to the 1/2. We can also write this as the square root of x multiplied by the square root of y. Now you might be saying, why does this make any sense and why am I using this? Well, we're not always going to have perfect radicals. So for example, the square root of 50. So what I'm going to do is I'm going to do a factor tree for the square root of 50. So I can say, okay, well, if I divide that by 2, I get 25, and then I get 5 and 5. Now, this is a square root, so I'm going to collect any pairs that I have. So I'm going to keep 5 times 5 as 25. And I can rewrite this as the square root of 2 times 25. And again, the only reason I've written 5 times 5 together is because they're a pair and we're doing a square root. So for square roots, we want pairs. So square roots, we collect pairs. Okay, and now remember, this is also, I can write this as an exponent. So 2 times 25 all to the 1/2. And now I can use my power of power rules and write this as 2 to the 1/2 multiplied by 25 to the 1/2. Now what's really nice is, I know I'm going back and forth between exponents and radicals. Well, my leftovers here, the 2 that has no pair, I can write as this. And then remember, I'm just doing the square root of 25, and you should be saying, well, Ms. Kralbeck, the square root of 25 is 5. I already know what that is. And now all that's happening here is multiplication, so I'm going to rewrite this as 5 multiplied by the square root of 2. And now I've actually simplified this as an exact value. So this is simplified as an exact value. Alright, so let's do one with a cubed root. So I'm first going to do a little factor tree here. So I get 2 and 27, 3 and 9, 3 and 3. Now the important part is it's a cubed root. It might be a little bit hard to see there. I can write it bigger if you're not sure. So because it's a cubed root, I'm looking for triples. Okay, so I'm going to keep my triple together, and I'm looking for triples because it's a cubed root. Okay, so I'm going to rewrite this now as the cubed root of 2 multiplied by 27. Okay, now remember, I can write this as an exponent. So 2 multiplied by 27 to the 1/3. Okay, now because I have a monomial here, I can use this power rules, and I get 2 to the 1/3 multiplied by 27 to the 1/3, which is just the cubed root of 2 multiplied by the cubed root of 27. Oh, I forgot my little 3's there, my index. Really important to keep your index. Okay, don't lose that. And then, well, the cubed root of 2 I can't simplify, but the cubed root of 27 is just 3. So my answer I can write as 3 and the cubed root of 2. And I've now simplified this to exact form. Okay? Now, these in-between steps, I don't expect you to write every time. If you just want to go from here to here, that is perfectly fine. So if I just wanted to do this, so say I had the cubed root of 2 multiplied by 27, I can just write this as the cubed root of 2 multiplied by the cubed root of 27, and I can do that because a cubed root is an exponent, and then I can say, okay, well, this is just equal to 3 cubed root of 2. So my answers are the same. And that is all for this lesson.